Take a second. All right. Hi, everyone. Welcome. Today is Monday, January 23rd, 2023. Welcome to Intro to Linux Kernel Development. I think today we're going to mostly focus on Git and sort of, I have some slides. We have some slides prepared about Git, but I think that we'll also do like a worked example and go through maybe some of the problems people were having. We have assignment 0. I think those grades aren't totally finished, but I think by the end of the day, for the students who are in the UML class, that is, the students who are in the UML class, you guys already submitted, and the grades for those are probably soon, maybe tonight, maybe tomorrow. And I think, I think most people at least somewhat had something going on, but I think there were some other issues. We just want to go through it. And I think we'll think about how we want to handle it. I think that we don't want to be too harsh, but the purpose of the assignment was mostly to get people familiar with that. And if people are, I don't know, we'll see. Okay, so I'll start sharing my screen. And we'll go take a look at the slides, and then once we get into it, maybe I'll switch to the terminal a little bit, do some Git stuff. But can everyone see my screen? I'm on the course homepage, or the program homepage.
Yeah, you're good.
Great. So all the slides are available on the course page. This Git one is the one we're looking at today. These may get updated. Like some of these other ones are, we may change them, but whatever. Like this has always the latest versions of everything. As with everything, this is a sort of a living document. But if I open up the Git one, we'll talk about Git, and maybe I'll switch the terminal back and forth, whatever. But starting from the beginning, what is Git? Well, Git is an open source version control system. Well, and really that begs the question, like, what is a version control system? So, I think that it's somewhat intuitive, but there have been many different version control systems over the years, because it's, if you're going to work on software, it's really important to be able to track who's working on what and keep track of all the changes people are making. And especially if you're collaborating, right? If you're the only person working on the software, you can pretty much just have all the files. Maybe you have an editor that lets you undo stuff, and that's probably enough. Though even if you're working alone, Git can be very helpful. But especially if you're working on a team, it's really critical to be able to track what different people are doing. And so a version control system is basically a piece of software, a program that it allows you to track different versions of the code and make sure that you know what is going on. You can sort of take a snapshot of where the code is, and then people can work on it. And if different people are working on different things, you can reconcile, both their changes into one version that, that contains both of the changes, et cetera. And, it allows people to work without sort of stepping on each other. If I want to edit something, then I can work on this piece and someone else can work on another piece, and then we can combine our efforts and keep everything organized, versus just if it was all files that everyone was editing. What if I edited this file and someone else edited the same file, and, we collided. And so, a version control system is a piece of software that helps with this, and Git is a version control software. It is an open source version control software, and it's actually was initially developed by the Linux project, by Linus Torvalds and others. Essentially, they were looking for a good version control software. They were using one that I think it was not free. Actually, let me see if I can put this in full screen as well. I don't know if I may need to pop back out again, but everyone can still see it, right? So there was other version control software that Linux was using, and Git was developed because the other one was they were still going to have to start paying for it, and they wanted to make something that was better than it and that was also free. And so Git is now really the industry standard. If you are using version control software, it's almost certainly Git. There's like 2 or 3 other ones that people use. And this is not there's a difference between Git and GitHub. A lot of people use GitHub, but there are other things like GitLab and I know there are others that I can't think of right now. Many different people have different ways to host Git repositories, but Git is the command line program and the protocol that we use to deal with this, and almost all version control is being done using Git nowadays. The particular workflow that we're teaching you about with the patches and everything is a little bit intimidating, but it's still how things are done in the Linux kernel, and the skills that you develop working with Git, in this way, will be absolutely invaluable if you want to have a career in CS, or if you're, have a career in CS and you want to get better at it. Like this skill, every job, people, if you're working on a team, you're going to be using version control, and it's almost certainly going to be Git. And even if it isn't, the things that you learn from learning Git will help you with whatever version control it is. But so that's like enough preamble. What is Git? Why do we care? Let's actually get into what it is. So I guess I started talking a little bit about this, but it's essentially version control allows you to manage the changes to a project, and it's specifically designed for programming projects. It essentially provides you a log of all the different states of the project, and you can look at previous instances, and people can also sort of work in parallel. As I was saying, Git is not the same thing as GitHub. GitHub is a website where you can host the repositories and share them with people, but it's not exactly the same thing. There are also alternatives to it. Git, it basically allows you to have a list of these previous states to keep track of previous states of your repository. This word repo is short for repository. Repository is basically a bundle of code. It's sort of one project. It's sort of the unit of Git. And so I guess if I switch to my terminal really quickly, I'm here inside of this KDLP assignments folder, but it's also a Git repository. And actually I can tell because it has this inside of here. If I use the -A option, if I just do ls, right, I just see these ones here. And if I do ls-l, it doesn't jump. But if I use LA, that'll show me all the ones, including like hidden files that start with a dot. And there's a folder actually that's hidden named .git, and this is sort of what makes it a Git repository. If I look in there, there's a bunch of stuff, and this is all sort of metadata that Git keeps track of. On top of, my code just lives freely in here in regular directories and regular files, etc. I can organize this stuff however I want, and then this .git folder contains all the information that Git needs to know in order to be able to track the different versions of my project. This whole thing, these files and these folders and this .git directory are a Git repository. And I can have one on my computer. There can also be ones that you can access on the web that are sort of being shared. But at the end of the day, it's a Git repository, and you're just looking at this repository. And I want to introduce this visualization as well. That will, we can obviously compare how this looks in the terminal, but these pictures will hopefully help with sort of a mental model of how Git is working. It sort of is like a tree-like structure where each version, every version has to come after some version, but there can be multiple versions that come after a single version. Each version can sort of have multiple children, but each version has exactly one parent. Well, no, not exactly. There are situations where things come back together again, but generally you can sort of flow backwards and see back from some single root, commit that is the very beginning of it. You can see how the history sort of branches out. And this is why we call it a tree. It's like a tree with roots and branches and so forth. And I know we talk about branches. That's a meaning that's, it's sort of connected to this metaphor of trees that have branches and so forth. A Git tree is like this repository and all these branches, all these things. We use these words because it sort of relates to this metaphor. But here, this is like the beginning of this thing, and each of these dots represents essentially a snapshot or of the thing, what we call a commit. And we can see the time progresses forward here. And this sort of line, I think people can see my mouse pointer, right? That's strange. I'm not sure why that's not working, but at the very bottom, we have this single thing, and then I'm looking at these two circles that are sort of stacked on top of here. We're calling this the main branch, and this is sort of almost every Git repository sort of has a central location, which is sort of the most preeminent, most central thing. Usually, the main branch, main or master, are common names for this branch, and it's sort of the the definitive version of the current, whatever the latest thing is. But there can be some other places where active development is happening, but this is kind of usually used to store whatever the latest sort of finished version of the code is. And then we can see there's also another place here. We'll call this the X branch, which is sort of splitting off from this bottom commit. And then this blue dot that's inside of there, this is how we're going to represent where you actually are within the tree. Basically, inside of here, obviously I see all these folders and all of these files and everything, but I can only see one version of it at a time. Essentially there can only exist, within this particular folder, there can only be one version at a time of these folders and their contents, right? And so essentially, that's the working tree. That's where we're sort of working. And basically this blue dot will represent essentially which commit that we're sort of standing at. And we can navigate this tree to visit other places. But this blue dot will be representing where we are. Yeah, so essentially we can see a directed edge to show how things are connected. This blue is a pointer to the current, where we are currently. We'll be using a dark gray for something that has actually become a commit that's essentially a saved state of the repository. And if we start making changes, we're going to represent something that isn't committed yet, but that we're working on in sort of a white circle, an unfilled circle. And actually, yeah, did someone raise their hand?
I just had a question. The blue pointer that you just talked about, is that like the head of the Git?
Yes, that's what we would call the head. Yes, the blue will always be where the head is. Yeah. And
yeah, head, you usually see it with like capital HEAD for anyone who's wondering.
Yeah, and so there are certain situations whenever you need to provide a commit. If you're ever supposed to provide a commit ID, there are certain ones that you can use. You can use the name of a branch or the name of a tag, or you can use this particular thing, capital HEAD, head. That is, it will represent where you. It'll represent where this blue dot is basically in the picture. So yeah, the first sort of way that you can create a Git repository is this git init command. And you basically do this while you're within a folder, and it will create a .git directory inside of that folder, and it'll sort of set it up so that this folder and its contents can become a Git repository. So you essentially either need to take a folder and make it into a Git repository with git init, or there are other ways like cloning an existing one. So if I just want to start a new project completely on my own, right, I could, let's see, if I go make a directory. I don't think I have anything named example. Yeah. So I'm going to cd into that directory. This is a nice little shorthand that this exclamation point $sign will grab the last argument to a command, the last command that I ran. So that will run the equivalent of this command. So anyways, I just wanted to explain that really quickly. That's, its own thing. Yeah, so I made this folder, right? And if I look in here, there's nothing, right? But if I do git init, it will say a bunch of stuff here, but the main one here is initialized an empty Git repository in this folder within my documents directory. And if I look now, there's this .git directory. And yeah, this thing is just telling us that the name of the main branch is or the master branch is master. This is just the default, but they're saying you can change it if you want. So yeah, this is an example of how you can create one, using git init, or I already have an existing one in here, and so I'm just going to remove that. I'm probably going to need rf /example. Yeah, so you'll need to be in one, and one you can just make a folder and run git init to create a new repository. But another way is to clone an existing one. And actually, you can clone one that you already have on your machine. You can have one that is literally a local file. You can clone it in multiple places. But there are also several protocols to fetch one over the internet, right? You could use like an SSH protocol that if you have a server that you can connect to using SSH, you can connect to it and it can send data for you to access about the repository over an SSH connection. You can use HTTP or HTTPS. And there's actually even like a custom Git protocol as well that I think is sort of maybe built on top of HTTP. I forget exactly how it works, but there can be a custom Git like specific protocol that listens on a particular port. Actually, I think it isn't SSH or HTTP. It's its own whole thing that like uses a separate port and it's a separate protocol. But there are different protocols, and basically they're going to take the form of some sort of URI, a uniform resource. What is it? Indicator? Actually, I don't know what URI stands for.
Yeah, I think it's indicator, but let me check.
Indicator. Yeah, I don't want to say something. So if I go up and I guess I don't have a good example, but basically I can run git clone, and the way that I created this KDLP assignments is I did. But if I look for the last clone, yeah, here actually. So here I'm actually
Wait,
using.
Hold on. Let me correct that. Uniform resource identifier.
Identifier. Thank you. That actually makes more sense than indicator. So yes, here, right, and actually I could do SSH : / where I'm indicating that the protocol I want to use here is SSH. So here those ones look like a user at some account with a colon and then some path, right? This is an SSH protocol. I could also use something that looked like HTTP or HTTPS : / and I could do github.com / and this would also work. And actually, this is the one that you would be, maybe with HTTPS is the one that you'd be using to actually clone it. I used the one that is SSH based because for authentication, I wanted to be able to log in. Whereas if you're just reading their, to be able to actually write to the repository, I needed some sort of authentication. So I prefer to use the SSH protocol for that. But there's other options. But I could also do something like file : / and then / I don't know, whatever, and I could provide some file. They're all, and I think there's also git : / but all of these are different protocols that you can use to clone a repository. And basically, this repository exists somewhere, and I want to just make a copy of it, and it'll copy all of the information about that repository, all of the branches, all of the commits, all of the files, etc. That'll all be brought into my copy. So, those are essentially the two ways to create one is you create one or you copy an existing one. And that's using git init and git clone. Now, these next series of commands are basically going to be how you actually do development, how you sort of, move things. And so I guess I'll sort of marry this with this example of going over what we did for A0. So, in this case, we're supposed to go into A0 and basically add a file. So I'm inside of this repository, and if I look in there right now, there aren't any files because I'm, and actually I'll mention this command really quickly. This git log command is very helpful. It essentially allows you to look at all the commits that have already happened. And so there actually are some in here already that, go back. And when I'm in here, I can just use the up arrow and down arrow. This is using my default pager, which I think is less on my particular system. But I can go up and down here, and if I want to get out, I can press Q. If it's shorter than a page, it'll not put you in the pager, but here it put me in the pager. So I can see the things that have already happened, but essentially none of the students commits that add anything and have been added, and I haven't made anything, so there's nothing in here, right? But if I want to make one, I could use my editor. I'm going to use Nano as an example, and I could use I think we're supposed to do first _ last, so I'll do my name .markdown.md, and so I can put something like, hello, this is Charlie's file. I like programming or whatever. And so, now I have this file, right? And if I look, there's another important command, which is git status. It'll sort of tell me how my head compares with a branch. And also if there are any files that have not been tracked or have been modified. Basically, this is showing me how my current code differs from what the current repository, what the current head is. And so basically, git add will let me add something to a commit. It will either let me add the changes that I've made inside of a file, to the commit that I'm about to make, or it'll allow me, if there's a new file, it will say, include this. And so here you could add git add dot, which will add everything in the current folder, or I could provide a specific file. And so now if I actually look at here, you can see it sort of went from this red untracked files to changes to be committed that are displayed in green. And so essentially these changes are ready to get made into a commit. So when I make, when I make some changes, I could also, as an example, if I look at this README file, right, I could put something in here, right, and rather git status, we can see that it's been modified. And essentially, I either have to add the file to a commit, or I can restore it to how it was. So actually, in this case, I don't actually want to change this. So I could either do git add readme, or I'm going to do git restore readme, which will actually undo those changes. And so if I look in readme, the stuff that I typed there is actually gone. But so, essentially either you when you make some changes, if it's, you either need to basically include them. I mean, you can do it in multiple steps, but, in order to get this stuff to not be here, every change either needs to be included in a commit, or you need to discard it, basically. And so I can add the things, and then essentially, and here's this diagram where I made some changes. The head is kind of on this white circle that is, so here on the very left, the head is on this dark circle, which sort of represents whatever commit I just made. And then I actually edited some files, right? And essentially, they were changed. And then once I did git add, it's sort of like my head is at this unfilled circle where it's waiting to be made into a commit. And when I run git commit, it's going to move me to the last column where this circle becomes filled in because it's an actual commit. And essentially, it allows you to save that snapshot as a new, snapshot, a new place to work off of. So if I actually do that, and I'm actually going to use the -s option, because we're going to probably want that for most of our commits. This will add the signed off by message. And I could use, there are other options I could use. I could use A, which will add all of the, basically all of the changes to files that are already being tracked. Which if this is if you just quickly edit a file and you just want to make a commit, you can skip the git add step by providing this A option. If I want to just quickly provide a message, I can also do that with the M option. But I think the most general way to do it is, the most general is just not do anything. I'm going to do the S because it'll fill in the signed off by line for me. But if I just hit enter, it's going to actually open up my editor. And so you can see it's sort of filled in. It's filled in the signed off by line, and it's right up here at the top for me to type something. And it has some instructions for me, like, please enter the commit message. And this is essentially a message to describe what you did. Saying if you start a line with tilde, it's not going to do anything. And if you put nothing in here, the commit will be abandoned. So yeah, I'm on this master branch, and it's up to date with the origin one, but I'm about to move it ahead. And the changes I'm actually going to add are adding this new file. And so the first line is basically like a title. So add, I'll say complete A0. Add a file named charlesmirabile.md to the A0 folder. And so once I'm happy, I can save my changes in my editor. In my case, it's, Control S and Nano, and then I can exit out of the editor with Control X or whatever it is for your editor. And basically once I exit, gets waiting for that thing to finish, and then it'll look at what happened. And so if I do git status, we'll see that the working tree is now clean. There is no, this green stuff is gone. But this message here, so now before it was saying on branch master, your branch is up to date with origin master. But now it's saying I'm still on branch master, but mine is actually ahead of origin master by one commit. And if I look at git log, we can see this commit was just added. And so, it actually has this number. This is a hash that has to do with which it is, like commit. So this is sort of how we identify the commits, and then it has information about my author and who wrote it, me, with my email, and then the date that I made this change. And then here's the, the message and this and the signed off by, and then, the next commit starts below there. So that's commit. And then, yeah, we've sort of already been talking about Git status. I went a little bit out of order with this, but I just wanted to, I feel like Git status is obviously helpful for explaining this. So yeah, here's the commit, and I'll go over a little bit of this stuff. I think a lot of this is going to talk about pushing, which is definitely useful if you like this. You probably should know how this works. For this, we're going to be using the Git patches facility, which is different workflow. You're not necessarily going to be pushing anything in this class, but it's good to explain how that works. A push is basically, well, I mean, we'll talk about, I guess this is, yeah, if you want to push, essentially you need some sort of authorization. I'm not going to go over this in great detail because this is, again, we're not necessarily going to need to work on this workflow, but this has information about how to set up SSH keys, which are how you can authenticate with GitHub, so that you can push your changes if you want to do that. And yeah, I mean, essentially, this has information about how to make how to add a remote to a thing you already have or push. But I think that yeah, I think that the pushing we don't need to talk about the pushing in too much detail, and I don't want to. Yeah, I mean, we'll show this briefly. Basically, it allows me to add a new commit. So here's my local thing, and the remote thing is missing this command. And when I run git push, it basically synchronizes the remote. The remote almost has its own blue. It has its own version of head. We could actually draw this in blue if we wanted, where the blue would go on the circle in remote, and then once we pushed, it would move to the blue of the top of remote. It essentially synchronizes what I have with one of my branches, at least, with what is the equivalent branch on remote. And that just means that other people could view it. Another way that it can be done is with the patches, which is what we'll talk about soon. And then, yeah, if someone else, this one you will need to do is git pull. If someone, if I'm here and I've made some changes or whatever, basically, if someone else has made changes and you want to view the new changes, the remote will contain commits that my repository doesn't. In this case, now remote has more changes than I do, than my local does. And so if I do git pull, it will basically synchronize mine with the remote and change what head is. So I don't have a good example because there aren't any changes in here that I can pull, but it's literally just git pull, or I could specify if I want to pull from a particular branch, I can do git pull, and then I can provide the name of a branch. And so this is actually I don't know why it isn't okay. No, sorry, I thought that was the end of the slides, but no, there's more. It was just highlighting the tab for some reason. I mean, I hit a key. Anyways, so this concept of branches, we've mentioned branches a little bit, but we haven't really explained how to use them. And I think that they are, again, like sort of a person who's new to Git will often just not use any branches, and they'll just put everything inside of master. And they don't know how to edit commits. It's sort of like and I mean, look, I did this right for the first time that I used Git. Everything was, oops, I made a mistake. So then I'd make a new commit, and I would just keep pushing. Everything would just get pushed to master. Everything was in master, and all that I did really with the pushing was just I'd make a bunch of changes, and if I made a mistake, I would just make a new commit to correct the mistake and push it, and so forth. And then someone else would pull and they'd make some changes. And if I made some changes and someone else had made some changes and pushed, then that was always a nightmare. And I'd create these merge issues, and there was all sorts of, is not a good workflow. So using branches is definitely just so great. It just allows you to keep everything organized so that you can work on things in peace. And when you're ready to combine it with other people, it allows you to do that. So essentially the main thing will always be like the final version or the latest shared version, and then each person can have their own branch where they're working on separate things. And so you can, sort of branch off of main and work on your project. You're part of the project while someone else maybe they work on their part and they're ready to put it in main. They can, put it in main, and then you can essentially, having done your work separately, you can integrate it as you see fit instead of having to sort of them colliding inside of main. So essentially, if and I'm going to go back and basically make this commit instead on a different branch. So let me think about how to best do that. I guess I could show the patch thing. Well, I'll do something else. So if I do git branch, I just have the master branch right now, but I can make new branches using git branch and then a name. And so yeah, if I do git branch, let's do A0, right? If I do git, yeah, so it's still right. So if I look at git branch, sorry, and git branch with no arguments will list them. So I'm actually still on master, and git branch A0 just created it. If I do git checkout A0, and I look, so yeah, I think I'm still here. And so if I look now, it says I'm on branch 0, but it actually doesn't even have an upstream branch, so it says everything is okay. And so I can essentially look at the branches using git branch, and I can switch back and forth using git checkout. Yeah, git checkout. And here we're showing these diagrams, right, where we're on the main branch, and then if I want to switch to feature 1, I can do git checkout feature 1, and we can see the blue moves from where it was on the main branch over to feature 1. Yeah, and let's see here. Yeah, and I can also, if I want to do something based on main, I can also do sort of this process of creating a branch and checking it out in one step. So if I want to make another one, so right now I'm on A0, I could actually combine that using git checkout the -B option. Check it will actually make a new branch. So I can call it temp, and I can check out master, I guess. And so that will make a new branch. If I do git status, it will check out a new branch, but it's based on, if I look at the log, it's the same as master. And you can see actually here, it's actually showing next to the commits, it's showing the labels for them basically. So, head points to temp currently. I'm in the temp one, but this commit is also the current head, so I could say head, I could say temp, I could say master, or I could say A0. And then down here, it's saying this commit is actually what we call origin master. And it's also the head of the origin repository, where origin is essentially the version that's on GitHub. And so I have A0, but I guess what I'll show, right, is I'm actually going to quickly go to master, and I'm going to delete the commit that I made. Obviously, this is a little bit dangerous. Like these commands are, if you review git reset --hard, you better know what you're doing, because it's easy to screw stuff up. But that essentially allowed me to just undo this command. And so now I'm on master, and my branch is up to date with origin master. And if I look at the log, we can see that we're on master, and it's still the one that's the same as all these things. But then if I go to, let's see, I'll go to A0, and I look in there. Oops, keep forgetting git checkout A0, and you'll notice I did use tab completion. I mean, it depends on your setup, but for me, once I start type that much, I can just hit tab and it'll fill out the rest for me, which is nice. And I keep wanting to do ls. Let's see, git status. So here, okay, did I not? Okay, no, yeah, there it is. Git status, yeah, I'm on branch 0. If I do git log, we can see here A0 is now, head is A0, right? But then master is back here. Master, also origin master, also origin head. And actually this temp branch, I don't need this anymore. And so I can actually delete a branch if I want. I can do git branch -d temp, and it'll just go away. And so that's you can sort of manage these. You can create them using git branch or git checkout with the -b option. And of course you can delete them using git branch -d. And you can switch with them between using git checkout. But if I want to combine things, right, basically at some point if I have these branches, right? So if I look here right now, I'm in A0 and I have some work that I've done, right? I created this A0 file. I completed my version of A0. If I want to actually share this with people, I might, once I'm finished with this thing, I might want to put it back on master. And so if I actually do git checkout master and I do git merge and I provide A0, basically it will add it here so that now master has essentially included this commit. And I mean, of course, there are things that can go wrong, right? But if I do that, that's going to essentially fold in the tree. And I don't know if there's a good picture. No, I guess there isn't a good picture for this, but it's basically like it's forked off, and essentially it comes back in and, the head moves forward by some amount, right? And it has a new commit, master, gains a new commit or a series of new commits, depending on how you do it, where, those commits are sort of pointed to by the commits you made in this other branch. And that's sort of what merging is. I think there actually is a way, there's some command that'll show you like a pictographic sort of representation of the commits where it shows sort of the lines going in and out. I forget how to do that. I don't know if you remember, Joel or Dennis. I feel like there's some way to like color it and it shows like sort of, I don't know if if you've ever seen anything like that.
Yeah, what do you mean?
It might be in Git log probably.
Yeah, maybe.
Wait, Sephora, are you saying something?
Git log dash graph. Like
Yes,
graph.
that's yeah, that's nice. And then I guess
either dash graph or single graph.
dash graph. Try single, no, it has to be both, I guess. And so I guess maybe there isn't really much to show because it's all one linear series of things. But I think that if I undo this git merge, I'm just going to undo that commit. And I look at A0, right? I have this commit in here. Now I could have a situation where something else could actually happen inside of master before I added it back in. So actually let me, so I'm still on master, right? If I do something like A0, I'm already in A0, readme, and I put something in here. And now I'm just going to use the git commit. I'm going to use the -a option to just grab this modification without needing to run git add, and I'm going to use the S options that it's signed off by. Not a good commit. Add stupid stuff to readme. So now I have one more commit, and if I try and do git merge A0, I think that maybe, yeah, so here it will create a new commit that's like a merge commit, right? And I think that if I look at the log here, so we can see it essentially added, here's the old branch, then I did this, then it added in my commit that I made a while ago from the other branch, and then I added this commit, and then there's this other commit that represents the merge of these things. I think if I did the graph on this, it would show, yeah, here we are, right? So here's master, right? And then I went forward and I made this commit, right? And then you can see it sort of branches off, and basically it was based on top of this commit. So you can sort of follow this green line here, and I made this one commit, but then basically to bring them back together again, right? You can see how sort of the thing it splits off, right? And I have two parallel things going on, the red and the green lines, right? And then up here, they come back together, and this commit essentially merges them. This is one workflow. There are other, I actually don't prefer this workflow. I prefer a rebase sort of based workflow. But let's see here. So I've made a little bit of a mess of whatever. So I'm just going to undo all of this. See your origin master. That'll just bring me back to where I am. And, all of this stuff goes away. And if I go into A0, it's still going to be there. Yeah, it's still here, but it's its own branch, which is nice. But so that was sort of an example of merging. And I guess we'll mention pull requests really briefly. If you're working with other people, you can create, there's many different names for these things: pull requests, merge requests, change requests. Like, I don't know, there's different ways of hosting a Git repository will have support for this, but it's basically like you can make a branch, right, that is on your version, and you can say, hey, can you take my branch and merge it into your branch? And basically it's, you know, some user interface that lets you say, hey, I want to add this, and then someone who's in charge of it can sort of accept it, and it can automatically run the Git merging process, assuming that they merge correctly. And so, you know, this is how people will collaborate often, is using pull requests. Though, again, with the Linux kernel, everything is done using patches, and so there isn't really pull requests. I mean, the name pull request essentially comes from, you would send an email to so-and-so saying, hey, can you pull from my branch, you know, and merge it in, right? And it, you know, at one point it was just an email, but now it's all very shiny and has a, you know, a website or, you know, whatever. There's different ways to doing it, to do it, but yeah.
I always did want to ask, why didn't the kernel development team overall adapt the GitHub workflow?
Yeah, well, so the emails have existed since before Git, basically, and so like it's just how they've always done things, and it's just gone back, you know, probably 30 years at this point. And so I think that the change from whatever other workflow they were using to Git, the emails continued, and, you know, really they host their own Git server. I mean, the Git Linux kernel is on GitHub, but that's actually just a mirror of the actual one. Like, the actual one is git.kernel.org, and this is their own. I mean, I think it's cgit. Like, I think this is cgit is the interface that provides this. You know, this is what this is. But if I actually look in here, I mean, these are all the repositories that they manage, right? But if I find Torvalds, well, if I just look for Torvalds, yeah, kernel Torvalds. So this is the, you know, this is the Linux. So, I mean, there's an equivalent on GitHub, not GitLab, github.com. I look at Linux. I think it's Linux. Edit. No, Torvalds Linux. Yeah, you're right. So, you know, this thing does exist, right? But this is not actually the official. And you can see there's tons of people that are making pull requests here, and it's like none of these are you know, no one is even looking at these. I mean, I think there are some that are closed, but I don't know if anyone actually merges them. Yeah, they're all just closed. None of them are actually merged, because that's not how this works. You know, people come in here and they're like, oh, let me just make a pull request. That's just like not how. And so you could say maybe it's better, but I think that at this point, all the senior people who've been working on this project for a long time are extremely used to this email-based workflow, and it basically is just its own whole thing. You know, that it survived the migration from, I forget what they were using. Maybe it was Bitbucket or something was the thing they were using, I think, before you know, Git, and, you know, it's gone from Bitbucket to Git, and, you know, like, why would they ever stop? I guess they've always been doing the email thing. But yeah, I mean, if you're using, you know, I think basically, like, and the reason they started doing it that way is because, like, you know, this concept, I mean, well, I think that Git did not exist when they started, and the internet was, you know, or it was a little sketchy, honestly. Like, even the concept of the internet was, like, I mean, it existed right in the 90s, but people were still figuring out what the internet even was or what it could do. And the idea of having something like this was probably beyond people's imaginations at that point. And so, you know, people understood email pretty well. I don't know, does that sort of answer your question?
Yeah, I mean, they could always migrate, but I guess it's easier to just continue as they were.
Yeah, and I mean, I don't know, there is no particular advantage to it. I mean, I think that it's just, it would be a huge migration because of how many people are sort of working on the project, I think. And, like, they could host their own, like, I think they wouldn't migrate to GitHub, right? Maybe they'd use something like GitLab. They could host their own instance of GitLab. But I think they just don't want to be like, they want it to be, like, email is a federated thing, whereas, like, because it's like, I guess people could make, because I guess here's the thing is, it's like, within something like GitLab or GitHub, right, you need to let other people create their own, like, fork of the project, right, and make their own branches and then make pull requests, right? But it's like they wouldn't want random people forking their thing, and they're not going to put it on somewhere like GitHub. I mean, they could, right? And, like, you can fork it on GitHub and you can make changes and you can generate patches from those, but, like, they're not going to, like, host other people's things exactly. and like sort of the email is like it is a sort of federated, distributed platform that everyone is welcome to have an email address. Any server can be an email server, and they can just communicate to each other. And it's an open protocol, whereas something like a pull request or a merge request on GitLab or whatever, these are protocols that were invented by companies on their proprietary solutions.
Okay,
and so I think that it's
fair.
maybe less open, less whatever. I don't know. I think that's the rough idea. But yeah, I mean, I guess I'll go back to the slides really quickly, and I'll see if there's anything else that's good here. I mean, git diff is useful. It's similar to the diff utility that'll let you look at different view files, but I can do something like git diff between A0 and master, right? And it'll show me, so it'll sort of say, starting at A0 to get to master, you would have to delete this file, right? And get rid of all of this stuff, right? Or if I did it the other way, and I was saying, how would I go from master to A0? It would end up resulting in this file being created with this contents. And, if I'm in the middle of something, essentially, if I'm in the middle of making some changes, I can look at the changes to a particular file. So if I, look at readme, right, we'll go back in here and we'll put some stuff. I can do git diff readme, and it'll show me that I added this thing. I could also just do git diff in general, and it'll show me, both. It'll show me like all the changes to all the files if I made more than one. But I'm gonna undo that. Okay, and then here's the pull requests. Yeah. And yeah, here's a diagram of the merging that we saw earlier, where I made there was some other stuff that happened on master, but I split off. Then we can sort of see this chain of 4 things, and because I think the mouse pointer, you still can't see the mouse pointer, right? At the bottom there, in order, we're going to call master sort of this vertical thing, and we can see there's like 4 sort of commits on there, and sort of this feature 1 splits off after the very first commit, and then there are like 2 more commits that are made on the master branch, while 1 commit is made on this feature 1 branch, and then there's a merge commit that's created to bring them back together with this blue. And then the head, becomes sort of the amalgamation of all 3 of these things, based on whichever it did. And so there are, let's see, yeah, there are ways to, I think Squash. Well, I don't know if this is exactly what Squash does, because it says right here that it'll stop before. I think it will stop before making the merge commit, but I think that it's also like, I think Squash does something else. But again, like, honestly, I think you guys don't need to worry about merging. Like, I want to talk more about the patches, so I don't want to get too far into the weeds on this. You're welcome to like look at this as sort of a reference, but I'm just going to flip through these. Merge conflicts is a thing that can happen if multiple people are working on stuff and you both change the same file. You can get situations where when you try and bring them together, it's like, who should win? You both change the same lines of code. What should the lines of code actually be if 2 people worked on them at the same time? And Git is not smart enough to know how to do that. It's not a programmer. It's just a tool that, can look at files and see how they changed. And so you may have to go in there manually and say, hey, this is how it actually should be, to sort of, synthesize the 2 things. And, like, it'll say you have a merge conflict. But yeah, you'll need to resolve it manually. I mean, this is sort of a bane of everyone's existence. Merge conflicts are awful. This is, I don't know, this is sort of why I prefer a rebase based approach instead of sorry about the dogs, by the way. I hope you can't hear them too loudly. But anyways, a rebase, we'll talk about this maybe we have more time. We may not have time for it today, but rebase is a very powerful tool that essentially lets you essentially alter history, but it allows you to create a very linear sequence of things where you don't actually need merge commits. I mean, you have to, deal with merge conflicts still, but it essentially means that instead of these things sort of forking off and then coming back together again, you can just have your thing split off. And then when you run git rebase, it's basically if you just brought this stuff that happened in the past as if it happened here, you just bring it through time, forward in time. And there could be conflicts that happen when you do this, but you fix them. And then the merge is just a fast forward, you just say, this thing just becomes, it just sits on top of, the existing commits, as opposed to sort of existing in parallel and then you need to draw some, additional commit. This is very janky that I'm doing this with my fingers when I'm trying to explain this, but
I have a question. I just want to make sure I understand this correctly. So for example, if I make a branch and I work on a feature myself, and meanwhile I'm doing that, the main branch is moving forward,
Yes.
to something else. And then when I want to merge, I'm basically kind of behind on the
Mhm.
other stuff that's been happening on main. So what I do with rebase is I bring all the different changes from main into my branch
Yes.
with
Under
my
it.
feature, and then I can merge.
Yes.
Is
Essentially,
that
you.
rebase?
Yes. So you would do while you've made your things in, call it branch the feature, main branch and feature branch. You're in feature branch, you do git rebase main, and it's going to drop all the changes that you made on top of the new main instead of the last version that you looked at from main. You forked off at some point, but it's like, what if you had done this work in the past, starting from this current, head of
Right.
master, and it'll drop it on top of there. And you may have merge conflicts, right, because of this delta where you moved it, but you can resolve those as it goes through the rebase, and then at the end of it, the thing that's interesting is the commits will not be in chronological order, right? Because if you made these commits a while ago, they can have dates that are from this period when things were being done here, and they can actually end up after things that happened before, later than them, which is, or they can have a commit, like these things that happened earlier can end up after something that happened later, which is a little bit confusing, but it's nice because the whole thing is one straight line basically, instead of having these merge commits. I don't know. I mean, it's a matter of taste. But okay, we talked about git log a little bit. We talked about so forking is again another thing within GitLab or GitHub where essentially you make it's like cloning, except it's for essentially you make a clone that of something. A clone of a remote thing onto a remote thing instead of onto your repository. You have two things that are sort of based on the same thing, and this is sort of how this is all for these pull requests and merge requests to sort of create a relationship where this remote is based on this other remote. But I don't want to get into the weeds of this. Hopefully, someone wants to join. Someone can let them in.
I don't see the dialogue, but
well, let me look. I guess not.
You can just
I
continue.
already
It's
let
fine.
them in.
Okay. Yeah, so here we're talking about rebase. And so essentially, this is the diagram here where, you were working on feature one, right? And in the meantime, main, went ahead. If I do rebase, well, yeah, this is incorrect. I think this is backwards. So we need to edit these slides a little bit, but that's fine. I would not do it. If I wanted to accomplish this, I would actually sit on feature one. I'd be here. I'd be my blue head would actually be at the top of the yellow, the highest yellow circle. That is to say, I would not be on the main branch. This star next to main, it would actually be next. I'd be on feature one, right? And I would do git rebase main, and that will or master, whatever it's called, and that will essentially say, instead of you see this yellow arrow that's splitting main into feature one, it's like, what if instead of splitting and forking at this time in history, what if I had split at the current top of main? That's essentially what it says. That's why it's called rebasing, is that you could say that feature one is based on this lowest commit from master, and when we rebase it, we're saying, what if we changed what it was based on? And so we could say, now it's based on this top commit from main, and now the history is completely linear. There are other things that you can do with git rebase. Like git rebase is extremely powerful, but the most basic use of it is just this workflow of rebasing on top of changes that happened in another branch so that they can be merged as a single linear history instead of having a merged commit. Yeah, I mean, we don't need to get too much into cherry pick, but cherry pick is sort of a way to, what if instead of merging a branch, what if I just want to take one particular commit from it? I can provide the hash of that, and I can do git cherry pick. And so I see this one, I want this one, in my master, but I don't want all this other stuff. And if it's an independent commit, it applies cleanly, you may have, whatever. If you try and do this, you may get merge conflicts, right? But I can say I want this particular commit, and I can drag it on top of my thing without using git cherry pick, but providing the particular hash of the commit rather than. But I don't want this yellow thing. I just want this one commit, so I can drag it over using git cherry pick. Yeah. And I think there's this -n option will let you sort of try and do it without actually immediately making a commit if it gets stuck. Whereas if you want to edit things before you actually make the commit out of it, you can cherry pick and then use the -n option. So you get cherry pick with the -n option, and then it'll sort of set this up without actually making the commit, and then you can actually run commit to finish it. But yeah, and again, I don't necessarily want to get into the tags. Tags are just a way to label things. They're kind of like branches, but they're a little bit more. They're not really designed to move. They're kind of like they're like a branch in that they're naming a place in the history, except it's really more like the tags aren't their own. They don't have the same sort of weight as a branch. They're kind of a lightweight thing that you can slap on top of something that exists, and it'll just let you have a descriptive name for this place. People use them for things like releases. You know, when I hit version 5.0, I'll make a 5.0 tag that points to the commit that marked that place. And that it's literally just a way to provide a name instead of having to type in the hash. It's just a descriptive name. Yeah, so here I am. I just want to show some of the issues that I think people had. So I'm on this branch A0. I didn't have to make a branch, but I generally would recommend making a branch for your thing so you can keep it separate from main for master, so that if you want to, if we make a push or something, you can pull it into master without it disrupting your work that you're currently doing. So I generally think before you start working on anything, you should almost always make a branch for whatever you're working on, because you can always just merge it in and get rid of the branch later. But it's always, it's kind of a pain in the butt to go back and undo this. If you started working on it before you made a branch, then it's harder to go back and fix that. You can't put the toothpaste back in the tube, so to speak, so make the branch first. Just always make the branch. That's my advice. But, here we sort of went through this process. I think most people were able to get to this process. Maybe they didn't make a branch, but they were able to add the file and make a commit out of it. But the patches, I think some people, there's issues with Git send email. I think most people were able to format the patches, but the Git sending email was difficult. And the Git send email, there was part of it was this whole issue with the student, emails and everything. So that's just whatever, like we should have said, you have to use a Gmail or something, because whatever, there's all sorts of issues with, I don't know, like I wish it were easier to just send emails, and it were easier to configure Git send email with other hosts. But there just isn't a lot of information about how to configure it. And like whatever, it's sort of an advanced usage of your email. And a lot of, emails are just not even designed to be, it's not an open standard. There's kind of a lock-in where you have to go to their website and view it there. It's impossible to just like view it in your own thing if you want to, whatever. So I have this patch, and the workflow that we're going to be using is formatting patches. And so, here I am. I'm probably going to go up a directory so that I can put my patch in here. You can put the patch wherever you want, right? It's just a file. But so if I do git format -patch, and then I'm going to provide the number of commits that I want to make a patch out of. So there's just one commit, right? And so I'll do -1. That's for one commit. Then say we're going to call this my my draft, my initial submission. I'm going to use the --RFC option, which you could go in and edit later, but it's just easier to provide this option, and this option will make the patches RFC patches for me. And then I'm also going to write the cover letter, not 3 dashes, just two dashes, cover -letter. And that's going to let me, I think that's everything that I need. So it's going to format a patch. I'm going to take one patch, make it into a patch series. Out of one patch, I'm going to call these RFC patches and then provide a cover letter. If I hit enter, it's going to run it, and it's going to generate these two things for me. And, the version. Actually, I'm just going to delete these patches, and I'm going to provide the version number. Yeah. So I'll sneak that in there. You don't, if there's going to be just one version, you don't need to provide a version. It's totally fine to say, not put a version number if it's the first version. But honestly, it's just good to get in the habit of just putting V1 or, or you can put a space here if you want, but either way, V1, so it'll make these things. And now here we go. And so if I look in here, and these are just text files, right? They're not patch files, but they're just text files, and I can open them. I think a lot of people, I would say, look at your patches before you submit them. I think people just sort of, I guess the cover letter, you have to edit it, but it's just a text file. Go in there, make sure it seems reasonable. You can preview it before you send it. So whatever, I forget exactly what the format is for how you write this. Is it I don't know if we actually put a thing that you have to do it something like this, but maybe if we didn't, maybe we should. But whatever, here's where your cover letter would go. So, degree of, and again, I'm not going to fill in it all, degree of success, 100%, no problems, whatever, and I need to add I think some people forgot about this. I need to add my signed off by line. So, and I wish there were a way to make it do it automatically, but there is a -S option on the format patch, but it doesn't put it in the cover letter for some reason. Like that's honestly a bug. Like I bet I could file that. And or if anyone else wants to do that and wants to get a commit, landed in Git, I feel like there should be a way to make it automatically generate this signed off by for me inside of my cover letter. But signed off.
Speaking of bugs, I also wanted to mention the white spaces here aren't, I think, perfect, because at the very end, like the 2 dashes, it has a space at the end.
Yes.
2 new lines, stuff like that. I don't know.
Yes. You've caught me in my dastardly plan to make a mistake so that I can demonstrate how to fix mistakes. Yes. I am aware of that, and in fact, I did it on purpose. But yes, we will see that in a second. Now, I actually can't remember. Does the space go here or not? I mean, I can look at the other one, I guess.
I think it does. It's just signed off by.
Oh, yes, signed off by. Okay. Yeah, and I'm just going to pull up the other one as well so that I can. Yeah, and I'm just going to copy it. Like here it is. Like, why am I typing it when I can just use copy and paste? Yeah. Okay. Nice. And I mean, this stuff doesn't really matter, but this is basically information about a summary of your changes, right? So it's nice to have that. And then all this stuff is just whatever, like version information, and anything below here is essentially not part of anything important. But okay, here it is, and so I'm happy with this, and this one I'm also happy with it. And so sort of when I make these patches, right, just text files, right, and I can send them, I can provide them to Git send email. But I'm not going to demonstrate that just to save a little bit of time, but whatever, you do Git send email and you do these things to submit them. But I want to show, before you even do that, you should essentially verify that your patches are okay. So the most important thing is to make sure that they apply. So on top of master. So right now I'm on A0, which means that I already have this commit that adds this file, right? But I'm going to make a new branch. I'm going to check out a branch, and I'll call it temp or something. And I'm going to use the master branch as my basis. In fact, I'm going to use origin master, because I want to make sure that it's based on whatever the most recent, commit that is actually like publicly available on that everyone can see versus whatever I might have in my master branch. Like I just want to base it on top of here, and it's going to, follow this thing, and it has, only the stuff that's upstream. And I can verify that it's correct by using the git am command. And I don't need the cover letter. If I try and apply the cover letter, it's going to say patch is empty, like it's not really a patch. So I don't want to do that one. If you ever get into a situation, so if I do git status, it's going to say, you're in the middle of an AM session, the patch is empty, you can skip it, or you can whatever. But I'm going to, if you ever like have an issue with this, I'm going to run git am abort to just cancel this operation. And now it'll return me back to being normal. But this time I'm just going to apply the correct file, which is the v1.001 complete a0.patch. And if I apply it, well, so there's essentially a mistake here. It applied, right? But warning, one line adds white space errors. So that's not good. Essentially, it's because if I look at this patch, complete a0.patch, you can see there's this extra line that's being added at the bottom there. And so that's not good. So I'm going to go back to master really quickly, and I'm going to just delete that branch because it was a failure or whatever. And here I'm going to actually need to use capital D to like force it to delete it, because there's some commits in there that haven't been merged anywhere, but they were kind of garbage anyways, right? They had this issue, so I'm going to get rid of that branch. And I guess, yeah, I'll show something, right? I could, you might think, okay, well, I want to fix this. I could just go in here and edit my patch, right? And so if I try that, I'm gonna try this. You shouldn't do this, right? But if I try this, I'm like, okay, I fixed it, right? It's no longer has this thing, right? And I edit this patch. It is a text file, but you really basically should not edit anything, below this triple line. Essentially, is the upshot. Because if I try and apply this patch, so I'm gonna check out. I'm gonna make temp again, right? And I just used the Control R, which lets me search for previous commands that I typed. So that's a nice thing if you don't know about that. But so I have temp again, and this time when I try and add my v1.001 complete, oops, basically corrupt patch, right? So this is why you should not edit the patches, or the patches at least below the triple dash. and start messing with the stuff that's actually like supposed to be machine readable. If I edit it, basically I deleted the line, but I didn't actually change some information about how many lines I was adding or deleting. But again, this is just not the right way to fix it. So you should not do that. Instead, I should regenerate the patches. So I'm actually gonna go back to my A0 thing. I'm gonna show how to edit these. So if I'm gonna look at git log -p. That's gonna show me the actual changes I made, and you can see here's the mistake, right? Where I added this extra line, and if I look at the file, we can see right here there's like an extra line, right? And so I don't want that, right? So I can delete that. And now if I do git status, right, I've modified this file, right? And I'm going to go through the process of making a commit out of it, but I do not want to make a new commit. That's another problem that a lot of people had, is if I add this file, which I'm going to do, I could make a commit out of it, but I don't want to just do git commit, right? That's going to make a new commit. I guess I'll show what happens. If I do, and I didn't add the -s option, right? But if I look here now, okay, I fixed it, but it's 2 commits, so that's not right. I'm going to undo that, git reset. -soft, I think will get us to the point where this thing has been added, but I didn't make the commit. So that was the wrong thing. What I want to do is I want to use the git commit --amend with 1 M. I always spell it with 2 M's, but it's 1 M. Git commit --amend. And that will basically let me go in here, and you see it opens up the editor that lets me edit the previous commit. So it actually is going back and it's editing the message that was associated with that thing. I actually am okay with the message. I don't want to change anything with the message. But in here, if I look, I've made a new commit, but it's actually just replaced the old commit. It essentially allowed me to go back and alter history. I mean, this is sort of, if you've pushed this somewhere, it's not a good idea to use git commit amend or rebase because, it's sort of rewriting history. But this is all, in your local version, right? And so it's totally safe to do things that, only you have access to this, so you can just change it so that, it was like you never made the mistake. And if I look, git log -p, we can see that now there isn't this extra plus. And so I can generate my patches again. Let me see, format patch. This time I'm going to crank the version number up to version 2, and it'll generate them. And I guess I'm going to copy, well, I guess I'm just going to look at the v1 00 and v2 -000. So I'm just going to copy this stuff starting right here. All of this, I'm going to paste it just because I don't want to actually change the thing. Though if you change something, right, if you make a new version, you should actually indicate what happened. So you should, I should have really said, some previous number of degrees. But if I make a new version, I should say changes, since v1, and I should say fixed white space error, error in patch 1, basically. And whatever, you can put whatever whatever level of detail you want in there, but I should indicate how I changed it. I think that the v2, this is already good. And so now if I try this, I still have my I still have my temp branch, and I should be able to apply these. So if I do git am v2, now that applies and it's clean, right? And I do git log whatever, it applies cleanly on top of the current origin master. And that, that's essentially what it means. There are other things we can do. We can use the check patch script, etc. But this is essentially, you need to make sure that you try this. And if it doesn't work, you've done something wrong. It should work, basically. I think that's basically all I wanted to say about this. I feel like there's and the only other thing, right, is now that I have this thing, right, if I want to make the final submission, I still need to resubmit, right? But I need to make it a non-RFC patch. So I should get that format patch command, and I should go back to v1, and I still only want thing, but I don't want the RFC, basically. And I hope that will, I guess it will overwrite the other ones, but that's okay. I don't need the actual patch files. I mean, you could save them somewhere else, but when I actually want to make my thing, I need to make them non-RFC patches. And here it essentially removes the RFC here, and so if you make a submission for your final submission, it should be a non-RFC patch. So I think that's we're about at time, right? We're at time for the normal class time.